Hi everyone, and welcome once again to my YouTube channel. Today I would like us to look at how to solve GCE Advanced Level Mathematics Paper 2 2021. Okay, the advanced level. The first question here, Roman 1. Given that x minus 1 and x plus 1 are factors of the polynomial, as you can see, find the values of the constants a and b. Now, if they are factors, if we have that as factor, we have x minus 1 equal to 0, imply x equal to 1. So we obtain f of 1. If it's a factor, it means the remainder is 0. So f of 1 equal to 0. We substitute there. We are going to have a, 1 to the power 4 is a, plus 7, plus 1, plus b into 1, minus 3 equal to 0. When we arrange that, we are going to have a plus b. This 8, 5. It crosses, we have negative 5. That's equation 1. X plus 1 is a factor. It means f of negative 1 equal to 0. Okay? Which, when you substitute, you have a into negative 1 to the power 4, which is a. Negative 1 cube is negative 1, so we have minus 7 plus 1 minus b minus 3 is equal to 0. This implies a minus b, negative 7 plus 1, negative 6 minus 3, negative 9. When it crosses, is positive 9. This gives equation 2. Okay, that said, when we have the two equations to solve for the values of a and b by elimination, if you take equation 1 plus equation 2, since the coefficient of b here is positive 1 and down this way is negative 1, when you add the two, it gives 2a equal to 4. Okay, if 2a equal to 4, this implies that a is equal to 2. Now, when a is 2, we substitute in any. We have 2 plus b is equal to negative 5. This implies that b is negative 5 minus 2, which is negative 7. So that said, we have the values of a and b. Now, with these values of a and b, we have to use these values of a and b, that's a 2, b negative 7, to find the values of x, to solve the inequality f of x greater than 0. Okay, so the polynomial that we are using now will be, our polynomial is a, that's 2x to the power 4 plus 7x cubed plus x squared minus 7x minus 3. Okay, now having done that, knowing that the factor, knowing that it has two factors, x plus 1 and x minus 1, since it has those two factors, it means you have x plus 1, we can multiply at once and use it to divide, which will give us x squared minus 1, because the equation specifies that they are the same factors. So we are going to use this by long division to obtain the other factors, the other two factors. Okay. Now, so we are going to do the long division here, where we have our our value here. We have 2x4 plus 7x cubed plus x squared minus 7x minus 3 divided by x squared plus 0x minus 1. Okay, now we are going to do the long division. This is 2x to the power 4, 2x to the power 4 divided by x squared. We have 2x squared here. 2x squared times this, it gives 2x to the power 4. This one gives 2x is 0 plus 0 minus 2x squared. When we subtract that, we are going to have 7x cubed, okay, plus 3x squared minus 7x minus 3. 7x cubed divided by x squared is 7x plus 7x. 7x times that gives 7x cubed. Gives 7x cubed minus 7 plus 0 here minus 7x. When we go ahead to do that, we have this gives 0, this one gives us 3x squared, this one gives minus 3. 3x squared divided by x squared is 3. So we have plus 3. 3x squared minus, when we multiply, it gives 3x squared minus 3, which gives us 0 here. So when that is done, it means that quatic, our polynomial which was given, is written in the form x minus 1 into x plus 1 into, when you factorize 2x squared plus 7x plus 3, it gives us 2x plus 1 into x plus 3. 2x plus 1 into x plus 3. So those are the 4 factors of the polynomial. Those are the 4 factors of f of x. Because for us to solve that inequality in that question, we must start by factorizing and having all the factors, so that we obtain all the factors. Now for us to solve the inequality, where the inequality says f of x greater than 0, we are going to obtain our critical values. Our critical values here, what are our critical values? We have x is equal to 1, x is equal to negative 1, that's equal this to 0, x is equal to negative half, and x is equal to negative 3. These are the critical values. And we are going to arrange these critical values in order. Okay. Let's put our number line. We have negative 3. Yes, it should be here. Negative 1. Negative half. And 1. And it's strictly greater than. Okay, strictly greater than. Since these are those values, is the zeros. Okay. Now let's study the sign. We're going to study the sign. The sign here, students. Negative 3. Which number is less than negative 3? Negative 4. So you see that here, if you substitute, it will be negative minus negative. It will be negative in that case. And here, so you have negative. When you put negative 4 here, it will be negative. When you put negative 4 here, it will still be negative. So times negative. When you put negative 4 here, it will be negative. So when you multiply all of that, negative times negative times negative, there means all the region below this is positive. between -3 and -1 is -2. Let's verify. Let's verify the signs together. So let's verify the signs together. If you take -2 here, -2, let's substitute -2. -2 minus 1 is negative, times -2 minus 1, negative. -2, we want to know by the sign. Negative here is negative, negative. -2, yeah, there, positive. So we have negative times negative, positive times negative, negative times positive. So all of this zone is negative. Which number is between -1 and -1/2? -1 and -1/2. Okay, we choose a number between -1 and -1/2. We have -3/4. Okay, -3/4, you put here will be negative, you put here will be positive, you put here will be negative, you put here will be positive. So we have negative times positive, negative, and negative times, so all of that gives us positive, because we have negative here, we also have negative here, gives positive. Now between -1/2 and 1, we have positive half, right? Positive half minus 1 is negative. Positive, okay, positive here, positive here, positive. So all of that gives negative. Now greater than 1 is 2. Positive, 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 all through here. So what is our solution set? What is our solution set from this? They say for which it is greater than 0. So our solution set will be, where do we have greater than, okay, x such that x is less than -3. Yes, union here, because we have this position -1 less than x less than -1/2, union x greater than 1. Okay, so that is our solution set. Okay, the Roman 2, we are given an equation m log 2 base 3 is equal to 10 log 6 base 9. 10 log 6 base 9. Okay, now we can equally simplify this. This is already in base, this one is in base 3, this one can be written in base 3. So log 6 base 9 can be written as, to convert to base 3, it means I will take that log 6 base 3, log 9 base 3, okay, which will be log 6 base 3, all of that divided by 9 base 3 is 2. So all of this can now be written as, this means that equation becomes m log 2 base 3 is equal to 10, right? 10 into log 6 base 3 over 2, which is 5. It gives us 5 log 6 base 3. Now this implies m, for me to solve for m, we're going to divide both sides by log 2 base 3. So we have log 6 base 3 divided by log 2 base 3. Okay, that's all equation 1. So let's progress to the next question. Question 2. Okay, looking at the question 2. The table below shows the values of two continuous variables x obtained experimentally. It is known that they have that relationship, the relationship between these values for the experiment. A over s plus b over y is equal to 1. By drawing the graph of 1 over y and against 1 over s, estimate. Now, most often these are problems that need linearization, and for you to do that, you need to express in the form y equal to mx plus c, and here you have been guided equally. So what do we do from here? It means here we have to make sure it comes out in the form 1 over y. So we have b over y here, 1 minus b over x, right? As you want to have 1 over y here. Okay. By so doing, now they say 1 over y, there is a b here. If I divide here by b, divide all through by b, all through by b, I'm going to have 1 over b is 1 over b here minus a over b x here, which is 1 over x. Okay. Now doing it that way will give us, we're going to have 1 over y equal to negative a over b, alright, times 1 over s plus 1 over b. You see that it is in the form y equal to ms plus c, isn't it? So you will look at, when you look at it critically, you see a graph of 1 over y against 1 over s. We have gradient negative a over b, and the y-intercept will be 1 over b. Okay, it will be 1 over b. And when that is done, your value of a, that you obtain your value of b. To obtain the value of b, 1 over b is the y-intercept of that graph. So when you obtain the value of b, your value of b should be 0.5, and when you use it to substitute, the gradient is negative a over b. When your gradient, when you equate it to that, when you obtain the gradient from the slope, it's going to give you negative 2, and you make a the subject, you are going to have a equal to 1. Okay, when you draw your graph. And now obtaining this, the main thing is to linearize. Drawing the graph is not a problem. Alright, that said, we are going to go to question 3. That has to do with complex numbers and proofs. Okay, now talking about question 3. Question 3, Roman 1. We are given some complex numbers, z1 and z2. I will ask to express z1 and z2 in the form r cos theta plus I sin theta. Alright, having that, the main thing to do is we have our z1. R is the magnitude of z1, okay, and the magnitude of z1 there is the real component squared plus the imaginary component squared, all that square root, which gives us 2. Then the argument of z1 being in the first quadrant, we have as argument tan inverse of the I component is root 3, that's the imaginary component is root 3, and we have here tan inverse of root 3. Okay, and the tan inverse of root 3 there gives us, which is pi over 3. Now we equally look for that of z2. Magnitude of z2 is root 2, right? 1 square plus 1 square root 2, and the argument of z2 is negative tan inverse of 1, because we are in the fourth quadrant. Negative, when the real is negative and the imaginary negative, we are in the fourth quadrant, which gives us as answer negative 3 pi over 4. Negative 3 pi over 4. So this one, write it in that form. Our Z1 in that form is, we have our 2 cos pi over 3 plus I sine pi over 3. And our Z2 is root 2 cos negative 3 pi over 4 plus I sine negative 3 pi over 4. So those are those values in that form. Okay. Now, having obtained those values, we also evaluate Z1 over Z2 all that cube. Z1, that's the modulus of Z1, Z2 all that cube. We know that the modulus of Z1 over Z2 is the modulus of Z1 over the modulus of Z2. But however, here we have the modulus of Z1 is 2 and that of Z2 is root 2. All this cube will give us 2 cube over root 2 cube. 2 cube is 8. Root 2 cube is 2 root 2. Yes, we have root 2 times root 2 is 2 times, so we have 2 root 2, which is 4 here, 4 over root 2, which gives us 4 over root 2, which can still be written as 2 root 2 by rationalizing the denominator. That is root 2 here, root 2, we will give 2 root 2. And the argument of Z1 over Z2 cube, we know from argument of Z to the power n is n arc z. So we have 3 times the argument of Z1 over Z2. But from the properties of argument of Z1 over Z2 is argument of Z1 minus argument of Z2. Okay, which gives 3. The argument of Z1 is pi over 3 minus, that's plus 3 pi over 4. When that is simplified, it gives us the overall argument here as 13 pi over 4. Okay, 13 pi over 4 as argument, which also in the other part following the range negative 3 pi over 4. Now the other part of the question, which is Roman 2. In Roman 2, we are asked to prove that 9 raised to the power n minus 1 is divisible by 8 for all n. We are proving by induction divisible by 8 for all n. Okay, now by induction, it means you have to verify, is it true for n is equal to 1? Alright, verify n is equal to 1. We have 9 to the power 1 minus 1, which is 8. So this means it is true, it is divisible. 8 is divisible by 8, right? So it is true for n is equal to 1. This implies it is true for n is equal to 1. Okay, now the next step is that we assume it is true for n is equal to k. That is, when we say it is true for n is equal to k, means 9 to the power k minus 1 is a multiple of 8. Let's say 8m. It's a multiple of 8. Having assumed that, we are required to prove that it is true for what? N is equal to k plus 1. And as I always emphasize, saying that assume it is true for n is equal to k, it means this is your ingredient. This is your tool that you are going to use to arrive at this. So n is equal to k, we have k plus 1 minus 1. We are going to use this. So whatever thing you are doing, make good use of this. We can write k plus 1 indices as 9 to the power k times 9 to the power 1 minus 1. Don't be tempted to say this 9 minus 1. No, you cannot subtract. This one is attached to this power. 9 to the power k is 8m plus 1 times 9 here minus 1. When we multiply to open up the bracket, what do we get? We have here 72m plus 9 minus 1. We have 72m plus 8. And when we factor out 8 here, we have 9m plus 1, which is 8l, where L is 9m plus 1, and all of that belongs to what? To Z. Is that okay? So having obtained that, hope we are together. Having obtained that value, now we see that it is true for n is equal to 1. It is true for n is equal to k plus 1, and hence it is true by induction for all n. Okay, it is true by induction for all n. So by induction, it is true. Question 4, we have here question 4. Given that f of x is sin x ln tan x, find f prime. F prime means the first derivative. So we're going to look for the first derivative when x is pi over 4. So here, in this Roman 4, we have f prime. We are going to use, which rule are you using here? Remember, we have many rules in differentiation. So which rule do you think we are going to use here? We have two functions here. In fact, we even have three functions. How do you identify? We have a product of two functions, sin x times ln tan x, which means we are going to use the product rule. Now, if I differentiate sine, I'm going to have cos x, then I will maintain ln tan x, plus, since I differentiated this the first time, I will maintain it, and I differentiate ln tan x. To differentiate ln, when you have, for example, ln x, you differentiate what is inside. When I differentiate tan, is secant squared, okay, divided by tan x itself. That is the answer. That is the derivative of that function. Okay, that is the derivative. Now, having done that, we can equally simplify this to give us cos x ln tan x plus secant square means 1 over tan, right? And 1 over cos square. And when we simplify that again, it gives us secant, thus it gives sec x here. Is that okay? Now, obtaining, they say the derivative at f prime of pi over 4, f prime pi over 4, we're going to substitute here directly. Okay, cos pi over 4 is root 2 over 2, and here pi over 4 here is 1. tan 45 is 1, so 1 times root 2 is correct. Here we have here pi, we have here the second value here is also root 2. Okay, now when this one gives 1, there is 0 here, plus 1 here is also root 2, because 1 over root 2 is root 2. That's 1 over cos 45 is 1 over root 2. 1 divided by 1 over root 2 is root 2. So our answer to this question is root 2. Now we're going to look at the Roman 2, for Roman 2, which is an integral. We're asked to evaluate from 2 to 10 over. Now one important thing to note about the method of substitution is that when you are asked to solve by substitution, is you are changing the variable totally. You are working with the variable that you have been given. Okay, you work with the variable that you've been given. For example, here it means this one that is in terms of x, you have to change it now. Like here, x now will be u squared plus 1. X will be u squared plus 1. Is that okay? And the limits will also change. So the integral becomes x, there will be u squared plus 1 divided by square root of x minus 1, that's u, okay? Then dx. So we're going to obtain here, if we are differentiating, we have dx will be 2u du. So dx becomes 2u du, right? And you see that here it cancels, okay, which gives us 2 u squared plus 1 du. When we are integrating it, we have u cubed over 3, right? You add 1 to the power and you divide by that result. When you integrate 1, it gives you u. That is it. That said, we equally need to always obtain our new limits, because as I said, by substitution means everything is changing, even the limits of integration are changing. It was 2. Let's see, it changed. It was 2. It's 2 minus 1. When it is 2 here, 2 minus 1, so u is 1. That's square root of 1. Equally 10 minus 1, 9, which gives u to be 3. Okay, so the new limits will run from 1 to 3, which gives us 2. This 2 is a constant, so let's work inside. This will be 3 cubed is 27 divided by 3, that's 9, plus 3. Okay, we have a mini bracket here. Alright, then when you substitute 1 here, we have 1 over 3 plus 1. Okay, that is 4 over 3. Alright, so doing that, solving that gives us 2 here. We have here 12 minus 4 over 3. When you do all of that, we are going to have the result as 64 over 8. That's 12 here, 36. 36 minus 4, 32 over 3. 32 over 3, which gives us, when you multiply by 2, it gives us 64 over 3. That is the value to that limit. Okay, sorry, that's the I mean to say the value of the integral after evaluating the integral. Okay, so to solve this, we are going to change sine 2x into 2 sine x cos x, and we bring them this way. You see, please don't cancel cos x. Say cos x is common, you cancel. No, that is not done. Now, having the first case, cos x is equal to 0, in that case, cos x is equal to 0, it means cos inverse of 0, it means our solution is already x is equal to pi over 2, right? Because cos pi over 2 is 0. Now, having this one as well, this one means sine x is equal to half. And we know sine is positive in the first and second quadrant, and half there means pi as sine inverse of a half, which is pi over 6. So we have pi over 6. Then in the second quadrant we have pi minus pi over 6, which is 5 pi over 6. That's done for that question. Now we equally have the second part, which is directing us to express in the form r cos x plus alpha. Expressing in that form. That's the Roman 2. You have been given a function 5 cos x minus 12 sine x, okay, that we should express in the form r cos x plus alpha, where alpha is acute. R cos x plus alpha. R cos x plus alpha, what does that mean? Means if you are expressing cos x plus alpha, we have cos x, when you are expanding cos alpha, minus sine x sine alpha. Okay, now when you are comparing the coefficients. Here we have here 5, which is the coefficient of cos x. If you expand this well, you see that the coefficient of cos x is r cos alpha. Okay, so we have r cos alpha is 5, and when you equate here, you see sine x, but there is sine alpha and there is an r here. So implies r sine alpha is 12. Okay. Now this is our equation 1. This is our equation 2. Now, being aware of the fact that sine theta divided by cos theta is tan theta, okay, it means you are not going to say equation 1 by equation 2. It's going to give you cut. You are going to say equation 2 by equation 1. It gives us tan alpha. And if you say 2 by 1, it means this divided by this, as well as 12 divided by 5. This implies alpha is tan inverse of 12 over 5. Alpha is tan inverse of 12 over 5, which gives us 67.4 degrees to 1 decimal place. And equally, likewise, our r will be 25, that's 5 square, plus 12 square, 144. That will be our r square. This implies our r is 169. That's the square root of 169, which is 13. So it implies, this implies that our function can be written as 13 cos s plus 67.4 degrees. Alright, that is how we were asked to express that function. That is what we were asked to do. Now the B part asks us to obtain the minimum and maximum values. Minimum and maximum values of 10 over the magnitude of 5 cos s minus 12 sin s plus 15. Okay, the maximum and minimum values. Alright, now how do you obtain the maximum and minimum values? Now to obtain the maximum and minimum values, all of this function has been changed, summarized to this. Okay, so it makes our work pretty easy. Once you have that has been summarized, that has been reduced to that, so we are going to use this function. Now, how do we start using this function? All of that function has been summarized to this, so let me reiterate using a red pen. So we know that the cos function, the range for the cos function is between -1 and 1. Okay, and how do I make this 13 to come here? I don't make this 13 to come here by saying 13 come here. What do I do to have 13 here? Okay, yes, that's good. You multiply through by 13. So we have -13 cos s plus 67.4 degrees less than or equal to 13. Okay, now having done that, it gives us this aspect already in the question that we have been asked. But now the question is talking, this particular question is talking about absolute value. And when you look at this is our function f of x also. Okay, between -13 and 13, it's already telling us that is the absolute value, right? The absolute value of that our function f of x less than or equal to 13. Because when you know the absolute value of when you put the absolute value in inequalities, it will be absolute value of x less than 2 means between -2 and 2. Okay, and which from here we have our value, we have our 15 that has been added. It's a plus 15. Remember, plus 15. Plus 15. And that absolute value here, plus 15, indicating the 10. So the question said 10 over absolute value of f of x plus 15. Absolute value of f of x plus 15. What is the absolute value here? We have this one, we have 13. We have 13 here. So if you are substituting for 13, we have 13 plus 15. That's here. If you substitute for 10, we have 10 over 13. 13 plus 15, which give us 10 over 28 from this value. Now, this is the minimum value. Equally, 0 here. We substitute, we have 10 over 0 plus 15, which is 10 over 15, which is 2 over 3. And here, 5 over 14. So this is our maximum value. Remember, this value is greater. It gives us our maximum value. So 5 over 14. This is our maximum value. This is the maximum, and this is the minimum. If you doubt, you can always compare. If you doubt, if you want to disturb you, once you have this value here, you compare. Okay. But I repeat, all of this is equivalent to the absolute value of f of x less than 13. But if the question did not have absolute value, well, we have to allow it that way and use the minimum and maximum. All right. Okay, thank you so far. Okay, thank you all. Thank you also very much for following up. Now, these are the first 5 questions of GCE 2023 Advanced Level Mathematics Paper 2. You can like, subscribe, share, subscribe, so that you are going to have the next set, that's from question 6 to 10. Once you subscribe, you'll be notified okay, about the next set of questions. That's questions 6 to 10. Thank you. Have a great time. Bye for now.